Something unusual is happening behind the scenes at Tesla, and it's not what anyone expected. While most automakers are busy chasing higher horsepower or packing their vehicles with flashy dashboard tech, Tesla has taken a different path, one that's almost gone unnoticed. Quietly, the company has introduced a new breakthrough that doesn't scream for attention, yet could redefine the future of electric vehicles. It's not software. It's not a flashy add-on. But it may very well be the reason Tesla has surged ahead of the competition. At the heart of this innovation is a component more likely to be found in aerospace than a typical garage, the carbon-wrapped rotor. This isn't just an incremental improvement, it's a reinvention of how electric motors work. Traditionally, rotors are made of metal, which can deform under the immense heat and stress of high-speed rotation. Tesla's approach replaces this vulnerable metal shell with high-strength carbon fiber, which maintains its shape and rigidity even at extreme rotational speeds. This results in a more stable, efficient, and reliable motor, especially under the demanding conditions EVs often face. But the true game-changer lies in how this carbon-wrapped rotor unlocks performance levels previously thought impossible in commercial electric vehicles. By eliminating the physical limitations of metal, the rotor can safely exceed 20,000 revolutions per minute, a threshold far beyond what has been typical in the industry. This opens the door to radical new designs, where motor performance is no longer bottlenecked by outdated material constraints. Beyond speed and durability, this innovation signals a broader shift in electric motor design. Tesla isn't just tweaking an existing component, it's rethinking the materials and structure at the very core of the drivetrain. Carbon fiber's lightweight and immense tensile strength allow for a more agile, robust motor that better suits the needs of next-generation EVs. This is not merely a performance upgrade, it's a future-proofing move that enhances longevity, adaptability, and engineering freedom. Ultimately, the carbon-wrapped rotor exemplifies Tesla's unique engineering philosophy, to innovate at the material level in order to achieve systemic advancements. While others continue to refine the limits of conventional design, Tesla has rewritten the rules entirely. This puts them not just ahead of the curve, but in a class of their own, potentially reshaping the electric motor landscape for years to come. And just when you think this breakthrough is all about raw engineering, Tesla hints that there's even more to come, something that could push the boundaries even further. Tesla's latest electric motor marks a major shift in how energy flows through every mile, fundamentally reimagining efficiency. Designed to convert electricity into motion with unprecedented precision, the motor delivers high torque and powerful acceleration while consuming significantly less energy than its predecessors. Instead of pulling excessive battery power, it optimizes each watt to stretch energy use further, offering a powerful yet battery-conscious driving experience. This transition from brute force to calculated performance is reshaping expectations for electric vehicle capability. A core contributor to this efficiency is the motor's ability to significantly reduce heat generation during operation. Traditional electric motors waste substantial energy as heat, necessitating complex cooling systems that sap additional power. Tesla's new design, however, remains cooler under pressure, cutting the need for thermal regulation and redirecting more energy straight to the wheels. This results in a more direct, cleaner energy transfer from battery to motion. For drivers, these advancements translate into practical benefits. Greater energy efficiency extends driving range per charge, meaning fewer charging stops and less wear on the battery over time. The motor's optimized performance not only enhances daily usability but also reduces maintenance and ownership hassles. In essence, Tesla's innovation ensures that every watt is maximized, less energy is wasted, more is delivered to where it counts, and the driving experience becomes both more powerful and more efficient. Beyond performance, Tesla has also tackled the cost barrier with this new motor. The design has been simplified to reduce component count and minimize reliance on rare earth materials, which are traditionally costly and difficult to obtain. By doing so, Tesla lowers both production costs and supply chain vulnerabilities. This streamlined approach not only eases material sourcing but also reduces manufacturing complexity, enabling quicker and more efficient assembly. Crucial to these cost reductions is Tesla's strategy of vertical integration and advanced automation. Unlike traditional automakers that outsource much of their production, Tesla maintains in-house control over critical processes, allowing tighter quality management and cost control. Automated assembly lines and high-precision casting systems enhance production speed and consistency while reducing labor expenses. As a result, Tesla's new motor isn't just a technological breakthrough, it's a manufacturing triumph that sets a new standard for performance, efficiency, and affordability in electric vehicles. Tesla's manufacturing advancements are enabling the company to meet increasing demand without a corresponding rise in production costs. By reducing the number of components, simplifying assembly, and lowering material expenses, Tesla can produce vehicles more rapidly than ever before. This faster production cycle allows for increased output while maintaining healthy profit margins. The savings achieved during the manufacturing process can either be passed on to consumers in the form of more affordable vehicles or reinvested to drive further innovation and expansion. This shift in production strategy is central to Tesla's overarching goal, not just to innovate, but to make innovation scalable and widely accessible. Through a complete rethinking of motor design and full control over its manufacturing pipeline, Tesla is achieving a rare balance between high-tech advancement and cost efficiency. This combination positions the company as a leader not just in engineering, but in long-term business sustainability. In contrast, traditional automakers face a significant disadvantage in the electric vehicle (EV) race due to their legacy design approaches. Many have attempted to adapt their existing internal combustion engine (ICE) platforms for electric vehicles, resulting in compromised designs. These retrofitted models often feature bulkier underbodies, suboptimal battery integration, and structural elements not suited to electric drivetrains, leading to heavier, less efficient, and more complex vehicles. Tesla, by designing its vehicles from the ground up as EVs, avoids these issues and benefits from better weight distribution and more integrated component placement. Moreover, legacy automakers are hindered by their heavy reliance on external suppliers. While outsourcing key systems like transmissions and infotainment modules was effective during the ICE era, it has become a liability in the fast-moving EV sector, where rapid iteration and tight integration are crucial. When innovation is needed, these companies must wait for their supply chains to catch up, a delay Tesla avoids thanks to its vertically integrated approach. Additionally, many traditional manufacturers are struggling to shift their technical expertise from combustion-based systems to electric technologies, further widening the gap between them and Tesla. Legacy automakers face significant bottlenecks and delays when attempting to upgrade their products, largely due to the limitations of outdated factory systems. These traditional production lines were originally built around combustion engine vehicles and are ill-suited for the modular, software-driven architecture of electric vehicles, EVs. As a result, transitioning to EV manufacturing requires extensive retooling, retraining, and logistical overhauls, processes that are both costly and time-consuming, and which introduce new vulnerabilities during production ramp-ups. Even with substantial investments into EV initiatives, these companies often struggle with inefficiencies as they try to adapt rigid, legacy infrastructures to accommodate fast-evolving technologies. In contrast, Tesla stands out not just for its products but for its speed of innovation. While traditional automakers remain entangled in years-long development cycles, burdened by bureaucracy and cautious decision-making, Tesla can prototype, test, and implement changes in a matter of months. This agility, driven by an optimized organizational model and relentless innovation, has created a growing gap, one rooted not in resources or talent, but in structural readiness for the demands of the EV era. Tesla hasn't just entered the high-performance vehicle segment, it has redefined it. With models like the Model S Plaid achieving 0 to 60 miles per hour in under 2 seconds, Tesla has joined a space once dominated exclusively by hypercars from Ferrari, Bugatti, and Lamborghini. What's revolutionary is that this staggering performance is delivered by a fully electric powertrain, offering instant torque without the mechanical complexity, lag, or noise of internal combustion engines. Unlike traditional supercars that rely on high-revving engines, fine-tuned exhaust systems, and aggressive fuel mapping, often at the expense of emissions and efficiency, Tesla delivers equivalent, if not superior, performance with zero tailpipe emissions and no gasoline required. The absence of engine roar or turbo lag gives way to a new kind of driving experience, clean, silent, and immediate. Tesla has made extreme performance more accessible and sustainable, transforming what was once the realm of exotic cars into something that feels more like flying than driving. Whether accelerating from a standstill or overtaking on the highway, Tesla's electric power delivery offers instant responsiveness that feels almost dreamlike. With no delay from mechanical components, the power is always available at your command. This immediacy, combined with Tesla's low center of gravity, thanks to its underfloor battery placement, results in remarkable balance and stability, even at high speeds. The outcome is a vehicle that accelerates with the ferocity of a rocket yet handles with the finesse of a finely tuned track car, all without the harsh ride or excessive noise typical of traditional supercars. Tesla has fundamentally redefined what a performance car can be. Historically, high-performance driving meant dealing with compromises like high fuel costs, constant engine maintenance, and impracticality for everyday use. Tesla has eliminated these trade-offs. Its vehicles rival, and often surpass, the acceleration of million-dollar supercars, while offering the space, comfort, and usability expected from a daily driver. This seamless blend of performance and practicality reshapes the notion of what it means to drive a high-performance car today. Rather than loud engines or exotic fuels, Tesla proves that the future of speed lies in smart, silent, and instantaneous power. Yet Tesla's innovation goes beyond raw speed. Behind the scenes, every mile driven contributes to a revolutionary self-driving technology. At the heart of Tesla's full self-driving (FSD) system lies a vast, ever-growing data infrastructure fueled by fleet learning. Each Tesla on the road functions as a sensor, capturing real-world data from millions of miles across the globe, from traffic signals and lane changes to unpredictable pedestrian movements and varying weather conditions. This data is fed into centralized neural networks, which learn to recognize, respond to, and predict road scenarios with increasing accuracy. Unlike other automakers relying on static maps or LiDAR-based systems within limited zones, Tesla's system trains its vehicles to perceive and adapt in real time, much like human drivers do. When a Tesla encounters an unusual situation, such as an oddly placed sign or a confusing intersection, it logs and labels that data to improve its driving algorithms. These improvements are then distributed across the entire fleet via over-the-air updates, ensuring that all Teslas benefit from each learning experience. This real-world, constantly evolving feedback loop enables Tesla's self-driving capabilities to progress at an unmatched scale and pace, setting a new standard in autonomous vehicle development. Tesla's approach to autonomy is rooted in observation and learning rather than rote memorization of driving routes. This allows its system to function effectively in unfamiliar environments and navigate real-world uncertainty, capabilities that often leave competitors struggling outside their tightly controlled test zones. Rather than relying on static programming, Tesla's AI interprets, learns, and generalizes from experience, which grants it a scalable, long-term edge. Its neural networks have become increasingly sophisticated, now capable of processing complex three-dimensional environments, detecting behavioral patterns, and making high-level decisions in real time. This progress is fueled not just by larger data volumes, but by higher-quality data sourced from unpredictable, real-world conditions. Unlike simulation-based training, which is limited to predefined scenarios, Tesla's real-world data acquisition continuously exposes its system to new variables, training it to adapt dynamically. As the fleet grows and the data pool expands, Tesla's full self-driving (FSD) software evolves, inching closer to full autonomy with every mile. Ultimately, Tesla aims to develop not just a self-driving vehicle, but the most intelligent and responsive driver on the road. Tesla's dominance in manufacturing is underpinned by its global network of gigafactories, strategically located to optimize production and serve regional markets efficiently. With major facilities in Texas, Berlin, and Shanghai, the company has established vertically integrated, high-output hubs that streamline electric vehicle assembly. These factories are far from traditional auto plants. They are technologically advanced, hyper-automated ecosystems where processes like stamping, casting, painting, and final assembly occur under one roof. The Texas Gigafactory, among the largest buildings in the world by volume, exemplifies this with its design optimized for end-to-end EV production, enhancing both speed and consistency. The Berlin and Shanghai plants are critical to meeting demand in Europe and Asia, respectively, while reducing delivery times and adapting to local regulations and consumer needs. A cornerstone of Tesla's Gigafactory strategy is its commitment to vertical integration. By producing essential components such as batteries, drive units, and custom AI chips in-house, Tesla has significantly reduced reliance on external suppliers. Manufacturing 4680 battery cells and key powertrain components internally has shielded the company from the global supply chain disruptions that have hindered many other automakers. This level of autonomy enhances quality control and provides Tesla the agility to scale or adjust production based on real-time market demand. The result is a highly flexible, innovation-driven operation that outpaces competitors in responsiveness and execution. Furthermore, Tesla's factory expansion strategy is also a calculated move toward strategic market penetration. The company is actively pursuing localized manufacturing in emerging markets such as India and South America, recognizing that the future of EV adoption in these regions will depend on local employment, affordability, and minimized import costs. By building gigafactories tailored to local infrastructure and policy environments, Tesla positions itself to deliver region-specific solutions and lead the next wave of global electric vehicle adoption. Tesla's strategic push for local production is more than just a manufacturing tactic. It represents a long-term investment in building market loyalty, securing regulatory favor, and solidifying the company's role as a central player in the global shift toward electric mobility. Establishing production facilities closer to key markets allows Tesla to sidestep tariffs and trade barriers, while also lowering logistics costs, ultimately making its vehicles more accessible to a broader audience. Through its gigafactory strategy, Tesla is not only redefining how vehicles are built but also reimagining where and why they are produced. Each gigafactory serves as a cornerstone of a larger vision in which manufacturing is as advanced and innovative as the cars themselves. With a foundation rooted in vertically integrated processes, scaled automation, and a design philosophy aimed at geographic scalability, Tesla is building a manufacturing network that can adapt to market dynamics, absorb global shocks, and outperform the traditional production models that have defined the automotive industry for over a century. The Gigafactory is more than a facility, it's a physical embodiment of Tesla's philosophy to reinvent every aspect of the automotive process, from concept to delivery, on its own global terms. In a stunning and unexpected shift, Elon Musk has recently reversed his long-standing stance on hydrogen fuel, marking one of the most talked-about developments in the energy and automotive sectors. Once a fierce critic of hydrogen technology, famously dismissing it as mind-bogglingly stupid and referring to fuel cells as fool cells, Musk had long pointed to the inefficiencies in hydrogen production, storage, and distribution as key reasons to favor battery electric solutions. However, in 2025, he surprised the industry by announcing that Tesla would begin exploring hydrogen fuel cell technology, signaling a significant change in perspective. This move, while surprising, is not without strategic reasoning. It reflects Tesla's adaptability to shifting market dynamics and its desire to remain at the forefront of clean energy innovation. The pivot is partly a response to intensifying global competition, especially from Asia. Chinese companies like BYD are expanding rapidly, offering affordable, high-volume electric vehicles that are gaining global traction. Simultaneously, Japanese automakers such as Toyota and Honda continue to champion hydrogen, banking on its long-term viability for clean transportation. Faced with a maturing battery EV market and growing credibility for hydrogen, Musk's decision appears to be a calculated hedge, ensuring Tesla remains competitive regardless of which technology gains dominance. Importantly, this move should not be seen as a retreat from Tesla's core electric vision but rather as a strategic broadening of its clean energy portfolio. True to its identity as more than just a carmaker, Tesla's embrace of hydrogen reinforces its role as a technology ecosystem, expanding its capabilities in the pursuit of zero-emission mobility.